Good morning, children. So let us discuss here alkynes. Alkynes are hydrocarbons which have in them carbon-carbon triple bond. And first, regarding the structure of alkyne, for that let us consider the simplest alkyne. The simplest alkyne is ethyne, which is CH triple bond CH. So this is the simplest alkyne. And now suppose what is the structure of ethyne? The structure of ethyne will be somewhat like this. And ethyne, is linear shape. So how it happens that I am showing you, in case of ethyne, the carbon atom is sp hybridized. Sp hybridized. Carbon atomic number of 2, its outermost configuration is 2s2, 2px1, 2py1, 2pz0, and in the excited state, one electron goes from here to 2s1, 2px1, 2py1, 2pz1, and here what happens is these two orbitals takes part in mixing, and this 2py and 2pz does not take part in mixing. So this two orbital mixing forms two hybrid orbital. That hybrid orbital, suppose I am drawing it here. So this is one sp. This is one sp. The two hybrid orbital will be making an angle of 180 degree with one another. So this is one sp, and the other sp is this one. So two sp has been drawn, making an angle of 180 degree with one another. This is on one carbon atom, and same will happen for the other carbon atom. So the other carbon atom is here. So it's sp with a smaller lobe, and the other sp with a smaller lobe. And they are overlapping with 1s of hydrogen. So we have got so far carbon-carbon bond. We have also got carbon-hydrogen bond. Okay, now what happens to this unhybridized py and pz? This is this is our 2py, and on this, suppose this is our 2py. So 2py and 2py will sidewise overlap, resulting in pi bond. So between carbon and carbon, sigma bond has been formed. Now a pi bond has been formed, and as you can see, there is another bond that has to be formed. So how is that formed? This 2pz is also there, which has not taken part in hybridization. And this 2pz and this 2pz being parallel will overlap sidewise. Okay, overlap sidewise, and another pi will be formed. So this is the structure of ethyne. We can say in ethyne carbon atom is sp hybridized, and it is having linear geometry. Okay, now you have studied before that carbon, the electronegativity of carbon, it it depends on the state of hybridization. Carbon which is sp hybridized, it is more electronegative than carbon which is sp2 hybridized, which in turn is more electronegative than carbon which is sp3 hybridized. This is electronegativity order. Electronegativity order. This is a very important thing to know. So why is sp hybridized carbon more electronegative than sp2, which in turn is more than sp3? It is because this hybridized carbon, it is having 50% of s character. This hybrid orbital has 33.33% s character, and this has 25% s character. Now s orbital is spherical, and you also know that p orbital is like this. It is dumbbell, and the probability of finding electron is like this. Probability of finding electron is like this. Now because of the shape of s orbital, s electrons are likely to be found more close near the nucleus. P electrons are not likely to be found very close to the nucleus. Since s electrons are found more closely to the nucleus, we use a term here that s electrons are penetrative. S electrons are penetrated, and because of s electron, very penetrative, then what happens is that this sp hybridized carbon is more electronegative. I mean, sp hybridized carbon will pull the electron of the bond towards itself. Like this one, suppose we have this ethyne. Since this is sp hybridized carbon, since sp hybridized carbon is more electronegative, so it will pull the electron towards itself of this bond. Why it will pull the electron towards itself? Because this is sp hybridized carbon, and sp hybridized carbon has very high s character. S character means the electron are very close to the nucleus. The electron will be very close to the nucleus. And what will happen if this bond electron is very close to the nucleus of carbon atom? This hydrogen will have a tendency to come out as H plus. This hydrogen will have tendency to come out as H plus. That means this compound will to some extent behave as an acid. Okay, you know that acid are substances which produces H plus. Similarly, here you see this substance, ethyne. Ethyne also will have tendency to release a proton. So from this, what we can say is that ethyne is acidic in nature. Ethyne is acidic in nature. So, since it is acidic in nature, we can expect this reaction to happen. CH triple bond CH plus say sodium, and since this hydrogen is acidic in nature, then what will happen is we will get this salt CH triple bond C minus Na plus half H2. So acid reacting with a metal, forming a salt, liberating hydrogen gas. So this reaction we can expect, and this is what happens. So this reaction, supports the fact that ethyne is acidic in nature. Now, if we have here, more excess of sodium, then what will happen is not only this hydrogen also will be displaced by sodium, and we will have this compound C minus Na plus triple bond C minus Na plus. We will get this compound. You can think in this way that this compound will again react with sodium to form this as a salt. This you can call it as disodium acetylite. So the fact that sodium reacts with ethyne to liberate hydrogen gas is a proof of the fact that ethyne is acidic in nature. And why is ethyne acidic in nature? The reason is that in ethyne the carbon is sp hybridized, and sp hybridized carbon are very electronegative. Sp hybridized carbon are very electronegative. Why electronegative? Because it has got 50% s character, and since it is highly electronegative, this bond electron will be dragged towards carbon that will facilitate the removal of this H, or will facilitate the release of this H as H plus. So this is a very important property. You should know that ethynes are acidic in nature. Now this reaction with sodium, it doesn't happen with ethene. It doesn't happen with ethene. It doesn't happen with ethane, because these hydrogens are not acidic in nature. The hydrogen of ethyne or alkyne, they are acidic in nature. So what, we can write one order here, acidity order. We can write one acidity order, that is your acidity order, that ethyne is more acidic than ethene, which in turn is more acidic than ethane. So these hydrogens are acidic in nature. Now a question I am asking here is that, is all hydrogen of alkyne acidic in nature? The answer will be no. So an example of an alkyne that I am giving it here. Suppose we have this alkyne CH triple bond CH2 CH3. So this is an alkyne, and this hydrogen will not be acidic in nature. This hydrogen will not be acidic in nature. Only this hydrogen will be acidic in nature. So remember, we can say that the hydrogen which is attached to sp hybridized carbon, that only will be acidic in nature. Okay, now coming to the preparation of alkynes. Okay, now I will tell you about preparation of alkynes.